We're interested in the proportion of people eating vegetarian meals at Manuel's restaurant. So first of all, let's say that P, the probability that we're interested in, is the probability that someone orders vegetarian at Manuel's restaurant. And we're interested whether that probability is different to Enrico's restaurant. So H0 would be that the probabilities are the same. Well, at Enrico's restaurant, the ratio of non-vegetarian to vegetarian is 2 to 3. So the probability of someone ordering vegetarian at Rico's restaurant is a third. And our alternative hypothesis, well, the key word here is different. We're interested in whether that probability is different to a third. So P is not equal to a third. This part here means it's a two-tailed test. So we're going to get a mark for doing the null and the alternative hypothesis, and then we're going to get a mark for saying if H0 is true, then x would follow a binomial. Well, we should probably define what x is first. So the data that we're getting in order to test this is out of a sample of 10, how many people ordered vegetarian meal. So let's say our random variable x is the number of veggie meals out of a sample of 10. So if H0 is true, then x would be binomially distributed with 10 trials because we're asking 10 people what meal they order. And if H0 is true, the probability of ordering a vegetarian meal would be a third. So at this point, I'm going to write down what would we expect x to be if H0 is true. Well, if the proportion of people ordering vegetarian is a third, we'd expect a third of 10 to be ordering vegetarian meals. So we'd expect roughly 3.3 of those meals to be vegetarian. So because it's a two-tailed test, if we see significantly less than 3.3 or significantly more than 3.3, then we can reject H0 and conclude that actually the probability is different to a third. So we basically got to work out, is 1 out of 10 small enough to reject H0? So the preferred method would be the p-value method, because that doesn't involve having to go through the process of finding the critical region. So with the p-value method, you don't need to draw the diagram, you can just think about it in your head, but I'm going to draw it to try and explain it. So along the horizontal axis, I'm going to put the specific values of x. So this is the number of vegetarian meals out of 10. So we could have 0 out of 10, 1 out of 10, 2 out of 10, etc., all the way up to 10 out of 10. And the distribution will look something like this, and the highest probability would actually be around about 3, because that's what we'd expect. So in our situation, only one person out of 10 ordered a vegetarian meal. So we've got to work out whether this is in the critical region. Well, our significance level was 5%. So remember, because it's a two-tailed test and we've got p is not equal to, we're going to half 5% and we're going to say the critical region can have no more than 2.5% in each tail. Next, we need to work out whether 1, if it is in one of the critical regions, whether it's in the left critical region or the right critical region. So we would expect, remember, if the probability is equal to a third, we would expect roughly 3.3 out of the 10 meals to be vegetarian. Well, we only saw one meal out of 10 which is vegetarian. So because 1 is less than 3, 1 is less than the expected value, we know that if we're going to be in one of the critical regions, it would be the left critical region. So we've got to work out whether 1 is in the left 2.5% of the distribution. So what we're going to do is we're going to work out what's the probability of x being less than or equal to 1. And we're going to use this distribution, the H0 distribution. And if you work that out, you'd get 10.4%. So remember, this is what we call our p-value. And now our significance level is 2.5% because we've halved it. So because our p-value is greater than 2.5%, that means we're not in the left 2.5% of the distribution. Because if you think about it, if we've got 10.4% at one or to the left, then 2.5% has to be to the left of where we are. So we're going to say 2.4% is greater than 2.5%. So we're not in the left 2.5%. So we're not in the critical region. So that means that 1 wasn't small enough to convince ourselves. It basically 1 wasn't small, significantly less than 3.3. So we're not going to reject H0. So do not reject H0. And we're going to say there's not enough evidence to suggest that the proportion of vegetarian meals ordered at Manuel's restaurant is different to that at Enrico's restaurant. An alternative method would be to use the critical region method. So let's try and find the critical region. So with the critical region method, I would have to find the left critical region and the right critical region normally. However, because we saw 1 out of 10, we know that we are less than the expected value, so that means that we would have to be in the left critical region. So all we need to do is find the left critical region. So let's do that. So if H0 is true, the probability of x being 0 is 1.7%, and the probability of x being less than or equal to 1 is 10.4%. So if we were finding our critical region, remember we can't have more than 2.5%, half of 5%, in the left critical region. So we would have to put our critical region as x equals 0 would be our critical region. Because we want the probability of being in the left critical region to be as close to 2.5% as possible, but not more than. So our left critical region is x equals 0. So that means we could only reject H0 if x was equal to 0. Well, we saw x equals 1, so we can't reject H0. So we'd say not x equals 1 is not in the critical region. So do not reject H0. And then we would make the same conclusion that we made before.